Hello, this is Mr. Merlo for lesson 4-5, scatter plots and trend lines. So this kind of goes along with 4-6 when we did the sequences. So scatter plots is basically putting those sequences on a graph and seeing if we can use it to predict what's going to happen next. So we need to know what a scatter plot is, correlation is. And there's three kinds of correlation. We have positive correlation, negative correlation, and no correlation. And then lastly, what a trend line is. Okay, so basically a scatter plot is just a graph, except once we graph these, we're not going to get a straight line or a V or U like things we've graphed before. It's just literally going to be random dots of what we're graphing because, patterns don't always happen, or, they don't stick to the same numbers every time. So if we're talking about football teams, a high school, or football scores for a high school football team, so in game 1 they scored 6, in game 2 they scored 21, in game 3 they scored 46, and in game 4 they scored 34. So just plotting the data. And then if we can kind of predict what's going to happen next, so we're just going to draw a line pretty much straight through these points to try to predict what's going to be the next score. So something kind of like that. Let us predict what do we think is going to happen next. So if we did have a game 5, it'd probably be about 40-ish points there. But again, it's a prediction. It might be true, it might not be true. Okay, correlation is how we're going to describe what the data looks like. So it could either be positive, negative, or have no correlation. And we're going to go through some examples here that kind of talk about what would be a positive correlation, what would be a negative correlation, what would be no correlation. Let's talk about what they would look like first. So something like this would have a positive correlation. You see from left to right, they're going up. This would be a negative correlation. From left to right, it's going down. And this is no correlation. The dots are just kind of splattered all over. There's no pattern for it. So looking at this one, so we're comparing the average daily temperature to visitors. Well, that's going to have a positive correlation. The hotter it is, the more people are going to go to the beach. If it's colder, people aren't going to go to the beach. Something like this, a snowboarding competition by year and the number of participants. This is also a positive correlation. So maybe something that started off not so popular in 2001 is growing in popularity, so it's going to get more and more people each year. So there's no graph here, but we just have to say what the correlation is. So the average temperature in a city and the number of speeding tickets given. This one's going to be a no correlation. Does not matter if it's warm or cold. You can still get a speeding ticket. So there's really nothing that goes with speed and the temperature in a city. Number of people in an audience and ticket sales, well, that's going to have a positive correlation. The more tickets you sell, the more people are in the audience. So both of those are going up. Remember, a runner's accumulated time and the distance to the finish line. So accumulated time means that the more they run, well, the closer they get to the finish line. And that is going to be true, and it's going to have a negative correlation because when one goes up, the time is going up, the distance is going down. Unless you're running in the wrong direction, when you're usually running a marathon or running a race, the more you run, that means the closer you are to the finish line. So one's going up and one's going down. So that's going to be a negative correlation. And then this one's talking about the number of members in a family and the size of the grocery bill. Well, that's going to have a positive correlation. The more people in a family, the more the grocery bill is going to be. This one, let's choose which one would make the most sense. So between the age of the car and the amount of money spent on repairs. So we have graphs A, B, and C. So which one would make the most sense for the age of the car and the cost of repairs? Okay, 2 of them we should be able to eliminate right away, pretty much leaving the correct answer. So A, we can eliminate because of this. The car's age can't be negative. There's no way that you have a negative 4-year-old car. So that would have eliminated A. Okay, B, the graph shows a positive correlation, so it could still be in play. Could still be the answer. And C said the correlation will be positive, or will be a negative correlation. Well, that doesn't make sense. You're not going to spend a lot of money on a new car for repairs. You're going to spend money on old cars for repairs. So that means our answer has to be B. So here we see, first year, second years, They're not spending that much money to repair a brand new car. But as the years go on, we're going to be paying a lot more to repair that car. And then a trend line just helps us predict what the next points are going to be. So if I have something like this, predict how much money will be collected at the concession stand when 150 tickets are sold. So here we have some ticket sales here, and we're going to try and draw that line just like I did on that first one and predict for 150 tickets. And we can predict if there's 150 tickets, you're going to sell about, I don't know what that says, maybe 730, 740, 750, somewhere in between there. And the book says 750. Okay, so they're not always going to be exact. Some of you could have different answers for that. We're just going to try and get as close as we can.